Right. A very good afternoon, ladies and gentlemen, and very good morning to Dr. Hoffman. My name is Raghavan Krishnamurthy, and I'm the director of Steerix. Steerix is an authorized partner of RWTH International Academy, RWTH Aachen University from Germany. So they are one of the top university in Germany and also pioneer in Industry 4.0. Myself has been appointed as a Malaysia rep in this collaboration. First of all, I would like to thank each and every one of you for your continuous support, interest, and participation. Right. So today is part 5 of our webinar series, the final part. The topic for today is Big Data Analytics, understanding and processing big amounts of information, extract more value from your data, and how we're going to do about it, how we're going to do it, right? So before we start, allow me to give a brief introduction about our speaker, Dr. Hoffman. Dr. Max Hoffman is the head of digitization and digitalization, manager at Institute of Production Technology, IPT, which is part of the Fraunhofer Research Organization. For numerous years, he has been leading the Industrial Big Data Group at RWTH Aachen University and managed major projects with the German manufacturing industry. Dr. Hoffman conducted projects on digital transformation with many large-scale German and international companies such as Volkswagen, Porsche, Saint-Gobain, and Bosch. Today, he will be giving his talk for 45 minutes and followed by another 45 minutes allocated specially for Q&A session. However, you can stop him halfway through and ask him if you have any question, right? Okay, so otherwise you can wait until the end of the talk and we can have a two-way discussion during the last 45 minutes, right? So without further ado, here's our speaker, Dr. Hoffman. The screen is yours.
Yes, thank you very much. So I also welcome you very much to this small introduction into the world of industrial big data. And what I would like to do is give you an understanding how you could extract information from data and how you could use the power of big data in your company to make your processes better and to increase your productivity and optimize your overall manufacturing. So first of all, you are very welcome to also share your screen video. Yeah, so it's always nicer, let's say, also for a speaker if he doesn't speak against a wall. Yeah, so if you would like to share your video that I can see your immediate feedback, how my talk actually comes to you, yeah, please feel free to do this. So good, let's jump into the topic. Let me share my screen. So do you see my PowerPoint representation now? Okay, looks good. Perfect. So let's jump into the topic. So what you see here on the first slide is big data in real time. Yeah, so here you actually see how big data evolves in the current world. How much data is produced every second, how much dollars, for example, Google makes with ads, yeah, and how much Facebook posts are being added, how much data they produce. This is all human-generated data. So it's a big amount of data which requires these companies here to constantly build up data centers, new storage operation, and so on. Yeah, and even, for example, Microsoft now starts building their servers into the ocean to save cooling costs. Yeah? So there's a tremendous potential in data, and all these companies here in social media and in this internet business basically have already understood how money making with big data works. But how do we do it in industry? In industry, there is a difference. Yeah. So if we talk about the classical big data, which you find, for example, in the internet or in the web-based business, then you see mostly human-made data. Yeah. This human-made data is mostly unstructured. It has a very high volume, velocity, very high variety of the data, while on the industrial side, the data is mostly machine-made, so mostly structured. But Unlike on the human-made big data side, where you can basically develop from ground up a solution in the green field, the industrial big data field is strongly characterized by the brown field. And this brown field means that we have a grown ecosystems of tools, of machines, of protocols, of MES systems and whatever which we need to deal with. Yeah, and this ecosystem here poses great challenges to us when we try to use industrial big data. And what I would like to help you understand in this talk is how you can transform your organization and the data gathering and the data collection in your organization in a way that you can make use of this industrial big data. Yeah, make use of it and turn it into value. So the overall goal here, of course, is to ingest all the information we produce in the field into some kind of cloud. This could be, for example, data from machines. This could be data from workers who run around in the field, in the shop floor. This could be data from logistics. This could be data from other machines and so on. And then we create our little databases, which we usually already have there, and try to integrate all this information into some factory cloud. Yeah, this cloud doesn't need to be a public cloud. Of course, it can also be a private one in the company if you don't want to trust any organization to give your data to. Yeah, so this is up to you how you build up this factory cloud. The most important thing, though, is that you are able to store all this information together in one place to reach this what we call holistic optimization, yeah, or the holistic production cycle here. So when you look at this picture, you see on the left side here, you see our factory. And as already said in the talks before, the first precondition for a successful big data analytics is the connection of the machines. So what we need to do first is connect all the machines into a network so that these machines are able to share their data and to share their knowledge, yeah, and to be optimizable by an overall process. Once we have all this data integrated into our cloud database, and we have this data ready there, then we can use two-way optimization. The first one, the classical optimization, which is traditionally used, you see on the right side here. Yeah, so there you see actually reports, dashboards, key performance indicators. Yeah, all these different numbers and these reports here can help the user to evaluate the situation, yeah, and based on this evaluation of the situation, to optimize somehow to adjust our production. But next to this classical step, we now also have AI algorithms. Yeah, you see this deep neural network there on top of the database. Yeah, and this stands for autonomous optimization and algorithms, automatic reasoning and automatic machine learning from data that has been integrated into this factory cloud. Yeah, and this way we can optimize and control our production together with the human and together with artificial brains. And this two-way optimization leads to our holistic process optimization. But gathering data is just the start. Let me explain you why. So, introduction to big data. What really is big data? Yeah, and in order to understand big data, we basically have to understand this four V's. If we try to define big data, it's not so easy because it's not about the data itself, it's more about the methods you treat the data with. Yeah? So to summarize this, big data is a vague term used loosely, if often these days, but put simply, the catch-all phrase means three things. First, it is a bundle of technologies. Second, it is a potential revolution in measurement. And third is a point of view or philosophy about how decisions will be and perhaps should be made in the future. Yeah, so this is a characterization of big data. And big data basically means that we have data which we are not able to treat with traditional methods. traditional batch storage, traditional batch analysis, and traditional treatment. And this is due to the fact that our data is too high in volume, is too fast growing, has a too high variety. That means like the heterogeneity of the data and the difference of each single data point that we have is too high, and the veracity, the trustworthiness of data. These are the three V's which makes it hard to process big data with traditional methods. Yeah, and I would like to use a few words about all of these four V's here in order to make you better understand what they mean or what they stand for. First, the volume. So the volume is the name giver of big data. Yeah, big data has, of course, a high volume, and how high this volume is, you can see when you look at the fact how quick data evolves these days. So when we look, for example, from the last 15 years, from 2005 to 2020, the digital universe has grown by a factor of 300. This is from 130 exabytes to 40,000 exabytes. And exabytes is a huge number, which is 40 trillion gigabytes of data. If you break it down to the people on Earth, that means over 5,000 gigabytes for every man, woman, and children in 2020. Yeah. So, and the rule that the data still doubles every 2 years is still in place. Yeah. So it's really amazing how fast data grows. Velocity is the second point here. Yeah, and the velocity basically is highly dependent on the context. If we look what velocity meant 200 years ago and what it's now, these are completely two different worlds. For example, 200 years ago, there was one man who made a fortune out of an information he had before anyone else had it. Yeah, this guy here on the left side here, Nathan Meyer Rothschild, he had the result of the outcome of a war in 1815 before everyone because a pigeon brought him this information. So this was the fastest medium back then. Yeah, using this pigeon, he got a letter, and based on this letter, he made a fortune then with a tea deal, I think. Today, velocity is defined totally different because today it's all about speed. Let's say, for example, in the stock market, yeah, and it comes so far that speed is really the determining limitation of how much money you make in finance. Yeah, for example, and this is why in the Wall Street Center in New York, every cable in the whole building which is connected to the main server has the same length. That means if your office is directly next to the main server room, you might have a pile of cable up to the sky, yeah, because it's not fair if your cable to the main server is shorter, because then you could literally print money by just buying and selling faster than all the others. So today it's all about speed, and data is generated very quickly and fast. Yeah? And we need to find ways in big data how to deal with this high velocity, with this high speed of information that we have. Variability is the next term. So big data is very manifold. It means very different. All the data points here are hard to describe using the same methods, using the same models, using the same rules. Big data is highly unstructured and is therefore meaningless in the beginning. I need to make an interpretation of this data, of all the data that I have, and I need to make this data understandable to be able to analyze it. One company, of course, here, which claims to understand all their data, may it be business application data, internet data, sensor data, social media data. One company who claims who can understand all this here is, of course, Google. And you see them with their Google car driving through a city here down on the right. And they claim, of course, they have they understand every pixel of their data. Yeah, so When this Google car drives around, it doesn't only see the streets or sees the roads. It also sees shops, names, businesses, points of interest, and they're able to automatically tag this data and mark this data in their maps. And this is because they're able to understand the diversity of data, yeah, to homogenize their heterogeneous data. Last but not least, the veracity. So this really describes how high is the precision of the data that I have, how high is the inner value, how trustworthy is the data, do I know the origin of the data, how quality related was the data measured. And in social media, this veracity term mostly refers to the trustworthiness of data. How can I trust the source of this data? How do I know if this is true or not? So, and in industrial big data, there's especially the term of dark data, which summarizes all the data that companies have collected, but which they do not understand and which they're not able to use because this data is not properly described. So dark data is neglected data that accumulates in log archives that nobody knows what to do with. Although it never sees the light of day, no one feels comfortable destroying it because it might prove useful someday. And I think if you look at your company, everyone can somehow relate to that, right? You have some data somewhere which you cannot really use, which you do not really understand, and which is stored maybe in a way which is not easy processable, but you still don't want to throw the data away. And this dark data is a real problem in the current industry because data is measured and data is collected and stored in low quality. And we need to change that in order to be able to use the value of the information that we have. So big data is distributed. What makes big data so different from traditional programming, let's say, is that in big data, not your data comes to your computer where your code is, your analytics code. Your code goes to the data. Yeah, so it's the other way around. The data is very big and is distributedly stored on many servers, many computers, and so on. And instead of moving the data from the storage place to your computer, which is not even possible with such high data amounts, you're just deploying your analytics code to the data. And then this code will add the data, this code will perform the analytics and will only synchronize back the result to you. This is modern way of big data processing, and this so-called distributed computing enables horizontal scalability. And horizontal scalability means that you can have any number of computers working in parallel on the same problem. And this way we can increase speed without limits. Every single classical computer has limits. These limits are of completely physical nature. The speed of the processor, the speed of the RAM, the speed of the hard disk. But if we can horizontally scale, that means if we can distribute processes and roll out processes in a parallel manner, then we are able to scale without limitations. And this is precisely what we need in a world which is dominated by distributed data sources with multiple domains, multiple applications, various users, and different sources for big data. And of course, it's not only a problem of AI. You know? Most of the time, and this is especially true for companies, the challenge is to realize the data availability and the IT infrastructure. So you need to be able to connect your data sources, to implement your data sources, to network them, and to gather this very distributed, heterogeneous, and not available in general data. Then, of course, if you did that, Then you can use your machine learning techniques that we examined in session 3. Yeah? Your supervised and unsupervised learning, your deep learning techniques. And you need to use your IT infrastructure or your cloud-based system to provide the necessary power to process the data. And of course, most algorithms which you will use in the end are somewhat hybrids and do not only rely on reinforcement strategies. Yeah? So you also will use a combination of supervised and unsupervised learning techniques here to use all of your data. But the first step to make this clear is to bring all these data sources that we have together. May it be enterprise resource planning systems, may it be manufacturing execution system, quality data systems, and so on. And this way we can actually make use of the data. And now, if we look at the last 20 years in networking and data processing in the industry, they have just focused on the automation optimization of specific processes. Now that we have all this different system distributed, all these different ERP systems, MES systems, and so on, and we're also adding IoT to the equation, now it becomes difficult because now we need to find ways how to bring all this information together and how to recombine all these data sources and also recombine them with usage data, product user data, and so on. Let's imagine you build cars, yeah, and you have a big problem because the brakes of all your cars somehow break down, or there's a specific user group who claims to have false brakes. Then you need to be able to track back, to trace back what was the problem for these specific vehicles in production. What could have caused this issue? You need to be able to track this back onto the machine, the process that was responsible for this. And in the modern world, in order to stay competitive, you need to be able to make this trace back. If you're not able to make this trace back, the competitors will be stronger and they will be more efficient. So big data ecosystems, how to start out here. How do you select the right tools, the right framework, and the right ecosystem to really build big data solutions that can be of actual use for your company and for your processes? When we look at the big data term and how much it has been searched and cited in the last couple of years, we see a strong uprise after 2011. Yeah, and since 2015-16, the interest in big data is very, very high. So it has been 7 years basically in which big data has been evolving. So when we look back in 2012, the big data landscape was quite, let's say, we had a good overview. Yeah, we have a good overview about the basic technologies on the bottom here, which enable distribution of data, and we had some infrastructure providers like Amazon Web Services, Microsoft Azure, and so on. We had some structured databases like Oracle, like MySQL, and so on. And we had quite a neat infrastructure of tools that we can use to make use of big data. Yeah, we also had some BI applications here, some techniques for structured visualization, for creating dashboards. Yeah, for example, Power BI or Tableau or whatever. Then when the landscape evolved in 2014, then we also had various data sources, which you see here in the bottom, which you can use to integrate more data. We had many more analytics applications. We have more specific applications for our specific use cases, for our specific business. And this grew throughout the years. When you look at 2016, this map becomes bigger and bigger. We have specialized solution for machine learning, for speech, natural language processing, for log file analysis. We have special application area programs for security, um, for life sciences, education, industries, finance. Yeah, we have all these different application areas here, which we could use different big data tools for, but we do not really know how. By the end of 2017, the big data landscape looked like that, and now it looks like this. So you see this big data landscape has constantly grown over the last decade. Yeah? And we have a high number, a tremendous number of tools which we could use if we wanted to. So the big question is, which of these tools are valuable for my company? And which of these tools, and how do I select these tools? How do I recombine these tools? How do I make sure I create a functioning ecosystem that works together with my old and grown machines, with my existing ecosystems of databases and so on? And also, how can I make use of the newest trends and technologies and libraries that I have? So to understand this process, you have to understand how the ecosystem dependency pyramid works. Yeah, so when you are only interested in renting an infrastructure from these providers, yeah, then you have a low price, but also a low dependence on these providers, of course. But in order to do this, you need a lot of in-house knowledge, and you need a lot of work to invest to build up all these big data ecosystems and all the tools based on the basic infrastructure on your own. Above that, we have the frameworks and the libraries, yeah, which are basically open source libraries which are free of use and which you can use on top of an existing big data infrastructure, which you can use to analyze data, to deploy applications, to process information also in a stream way. Yeah? And above there, we have the platform as a service level. And on top, we have the software as a service level. Yeah? So these two levels above, there you find tools which are highly specialized for your application domain and which are highly specialized in their purpose. They might be useful and they might be easy to implement, but for this you pay a high price, and most importantly, you are in a high dependence of the provider of these services. Yeah, the upside here, of course, is you need less in-house knowledge and you need less work to invest to create a functional system. But the dependency here is quite severe. This is why we recommend to start at the framework and libraries level. Get your infrastructure ready, and this doesn't really matter if you build your own server rooms or if you rent instances with Microsoft or with Amazon Web Services. But once you get your infrastructure ready, you can directly start out with big data processing using open source frameworks and libraries. And all these libraries which you see here, from Hadoop over Spark, over Jupyter Notebooks, over Uzi, TensorFlow, scikit-learn, all these machine learning solutions here, all these analytics tool suites. This is the major focus of all the training programs that we make. We help you how to start out with these open source libraries here and how to make use of them, to use your infrastructure, your existing machinery, and your existing data in a meaningful way. Yeah, so here you find all what you need. All this AI and machine learning and deep learning libraries are built up on open source Python libraries, which you can directly use to create value from your data. Industrial data lakes. So how can we design, how can we structure a functional ecosystem of data when we don't know how to store this information in the right way? And one solution to deal with this scalability problem is the so-called data lake construct. And I would like to give you a short introduction in how these data lakes work. So a data lake is for long-term data management of IoT data and of all kinds of data that I can integrate using distributed devices and distributed systems. Yeah, but a data lake is not a literal lake with zeros and ones in it. Yeah, it's way more than that. If you think of a data mart, so a classical database, as a store of bottled water, cleansed and packaged and structured for easy consumption. The data lake, in opposition, is a large body of water in a more natural state. The contents of the data lake stream in form of a source to fill the lake, and various users of the lake can come to examine, dive in, or take samples. So this quote here summarizes pretty nicely what a data lake is. A data lake is basically a generic storage in which you can store all the information that you have from your source systems, from your manufacturing execution systems, from your quality management system, from your enterprise resource planning systems, and all the other raw data that you have. This data will be integrated in a big body of data. And in this big body of data, you are able to examine all this information together and in a combined way. You are able to do transformation processing, query the data, and most importantly, you're able to use machine learning models to find correlations between the data from the different systems which you did not expect. So using this overall structure for bringing all this information together, you can finally recombine information sources which you could never recombine before. And of course, the data lake does not only work intra-enterprise. So it doesn't only work within your company. It also works from data that comes in from the outside, our extra enterprise data sources. And this, of course, is the product usage data and the user-generated data that I mentioned before. We have all these devices out in the field. Let's, for example, cars, smartphones, apps, and so on. And all these end user solutions, all these end user products, they generate data as well. And what I want to do is I would like to correlate this data which comes from the outside world back to my enterprise, and I would like to find patterns between, for example, possible problems which I had in a production and the actual usage data. If I can find these correlations between the usage of data and the production of my products, then I'll be able to perform this holistic optimization, which I mentioned in the very beginning. So how does data lakes technically work? And the main driver of the data lake concept is this so-called schema on read pattern, which is in opposition to the classical database schema on write pattern. So what does this really mean? If you look at a classical database, then you define your tables. For these tables, you have a fixed schema, you have a fixed number of tables, you have a fixed number of columns. All your data is nicely structured and fits perfectly in this database. You cannot really make big mistakes because the structure of the database already prevents you for storing the wrong format and so on. But all the data, before it gets integrated into the database, needs to be pre-processed. We need to maybe convert numbers into strings. Yeah, we need to make some calculations. Maybe we need to do some aggregations. So we need to bring the data in a form that it fits in our database. However, the data analyst wants raw data. The data analyst who wants to make use of big data does not want data that has been pre-processed. This is why using a data lake, we have the so-called schema on read concept. And schema on read means that all the data that we have is stored in their raw format. So there is no pre-processing involved, no transformation involved before we store the data into our database. This schema is only applied when the analyst reads the data. This is why it's called schema on read. And this way we can use our data in a very generic way and in a very structured way. And we don't have the problem that already information is lost due to some pre-processing which I don't want in the beginning. Yeah, so the data lake here enables a very generic way of storing information to the raw form and using them as they are from the field to find more patterns when I analyze them later. But if you store the data, you need to be very aware that your data lake doesn't turn into a data swamp. So because data lakes where data is stored without interpretable metadata will sooner or later collapse to the data store or to the data swamp. This actually means that for all the data that you store in your data lake, you need appropriate metadata description. And this metadata is, of course, can be a product ID, a machine ID, a timestamp, a precise location where the data comes from, and so on. So all this meta information, which I need to understand this data in a later point in time, become even more vital if I store my data in the data lake in their raw form. I do not pre-process the data to fit in my table structure, but this is why I have to be very careful how much metadata or how I will store my metadata, because this metadata will be very important in the schema on read pattern when the analyst tries to understand where the data came from or what the data means. And to compare it to the internet, the success of the internet doesn't rely on the big number of web pages. The success of the internet is about easy participation. Everyone can contribute, and searchability as well as accessibility of the information and not just data. And the same needs to be with your industrial data lake. Your data lake needs to be searchable. Your data lake needs to be understandable, and your data lake needs to be indexed. The same what Google does. Yeah? Websites and information sources come and go. They change all the time. But the internet as a whole, the internet as a functional ecosystem understands this and is able to deal with this, because big companies like Google or also Bing, for example, they create index pages from metadata, which makes it easy for you to Google for something, to find the information that you need. If you need a specific information, it doesn't help you that there is a billion web pages where you don't know where the information is that you need. The only way of making use of this billion web pages is an engine which is able to understand and to know where the information that you need is. And for example, Google does this with index pages. And in this index pages, all the metadata is stored. And the same you need to enable for the data you store. So you need to store all the information that you got from your various systems, from your MES systems, from your ERP systems, and so on. You need to store them in a way that they are easily searchable and accessible. What does this mean? Yeah, so the ideal data lake here, in order to enable such a query engine where we can generate reports, exports, yeah, and so on, the ideal data lake is extensible. That means we can add new data sources as we want, yeah, independent of their type. It needs to be accessible of the data. Yeah, so we need to have interfaces where we can access the data lake. Let's say an application programming interface, a database abstraction layer, and so on. And most importantly, the data lake needs to be searchable. So we need labels for all the data that we have in there, and we need metadata description for all the information that is stored in the data lake. And then we can use our query engine to generate automatically our reports, to perform exports, to finally employ big data analytics here, and to create our management cockpits and dashboards. And this is the way you have to structure your company. And yes, please let us help you how to do that. And with these words, I would like to thank you very much for your attention. And now we are open for questions.
Thank you, Dr. Hoffman, for your presentation. So, dear participants, now it's open for questions, so you can raise a question. You can feel free to unmute yourselves to ask question directly to Dr. Hoffman, right? We don't have any question in the chat box yet. Anyone from the floor? We have 30 participants.
Nice.
Yeah.
So you can also ask your questions in the chat, of course, if you don't want to speak up in this big audience here. Would be glad to answer any unclear points.
No questions? Ladies and gentlemen, please use this opportunity to ask your questions, right? So you can directly speak to the expert, right? He's well versed in Industry 4.0, especially come and talk about big data, right? So Dr. Hoffman, I think he did a lot of research and projects in regard in this topic. So feel free to ask him question. You know, it could be anything. You know, how to start at your place or where do you start? You know. Okay, we don't have questions yet. Let me see. But okay, Dr. Hoffman. So meanwhile, waiting for the question. So yes, we have conducted a webinar series. In particular order, an order that actually how we should embark into Industry 4.0. We talked about machine-to-machine communication, and then we talked about data analytics, and then now big data, right? So um, so we need to establish all this first, right? Like making the machine to communicate to each other first, and then we try to develop a data analytics model, and then only we can look into big data. Am I right?
Mm-hmm. Yes. So yeah, what we need to definitely do is every company these days, especially now, needs to gain their Industry 4.0 maturity. So all the companies right now, especially now that we have this full stop of production and this full stop which we have right now, should use the time now to increase their level of maturity here, because when you want to stay competitive after this crisis right now, we need to be ready. Yeah, and this maturity we can start, of course, with connecting our machines, but then we need to also think further. What do we do with the data when we generate more? How do we store them properly? And how can we derive key performance indicators based on that? Yes, and so basically all these different steps which we have talked about are the contribution to the Industry 4.0 maturity that all companies, especially in manufacturing and especially in the industry, should perform right now.
Okay, great. So participants, if you have any other questions besides the big data analytics, you may miss the first few sessions. So if you have any other questions, right, so you still can raise it right now, right? So today is the last series, last part of our webinar series. Definitely will come back again, but till then, you can use this opportunity to ask your question or raise any concept, Dr. Hoffman.
I think I saw something in the chat.
Right. Okay. So let me read that out. To develop a business intelligence system for a company, what are the important components need to be considered?
So yeah, ABI application is, let's say, the old-fashioned way of designing an optimization system based on key performance indicators, yeah, KPIs. So a BI systems have basically the same preconditions like all the big data systems we talked about. First, we need to have our information that we need to calculate our KPIs accessible. So we need to have all this information together, and then how to get a BI system ready for your company really highly depends on the application domain. What you definitely need, of course, is a infrastructure of your data. You need some sort of middleware system, and this middleware system is somehow the communication parts from your field level and from your external data to your processing systems. And your processing systems, then of course they can vary a lot depending on which application domain you're in. Yeah, but this is basically the fundamental prerequisite is to have this middleware which is able to connect data from the field or from the outside world to your visualization systems, to your processing systems, and to your analytic systems. May I ask if you have a specific BI system in mind, or if you work in a specific application domain, then I can be maybe more precise here to help you. Okay, so there's no specific application domain.
Okay, any other questions? Okay, she just wanted to know how.
Okay, yeah, so if you would like to develop a BI system, yeah, this can be done by, of course, various tool suites. Yeah, when you, for example, recall on the slide which we seen before, I can maybe show it again. The big data ecosystem, yeah, where we see all this information that we have. So here, this is basically all the tools you need to start developing a BI system. Yeah, so you have all the open source tools here. You have all the processing libraries. You have all the data storage facilities. You have all your database systems which you basically need, and then you can basically start out programming some solution with Jupyter notebooks and creating some dashboards and visualizing the data somehow. Yeah? What you also, of course, might need might be the backwards loop of this analytics outcomes here back into your production system. But this again really highly depends on the application domain where you work at. So I don't know if you're working with actual machinery or if you are working in I don't know, business processes, if you're working in finance or in consulting. Yeah, I don't really know where you work in, but how to loop the knowledge back that you gain by using this AI and machine learning techniques, this highly depends on the application domain. But if you just would like to implement a BI system, which is able to trace and evaluate your current information and show you somehow key performance indicators, then these libraries here might be sufficient or will be sufficient.
Okay, thank you, Dr. Hoffman.
Sure.
No more questions.
So if there's anyone working in a specific field, a specific manufacturing industry, or has a specific data-related problem which you would like to deal with, please feel free to ask here. I did a couple of projects with big companies where we gathered worldwide information together in one big data lake and gained quite some experiences here in doing so.
Okay. The participants are very quiet. We have plenty of participants from Finissa, if you still remember.
Yes, of course.
Yeah, so plenty of them from Finissa. So Dr. Hoffman, so would you be able to share some of your experience, like a real experience, as in like you have worked with numerous companies, and what are the things that some lesson learned? Probably you want to share something like that.
Yes, of course. For example, one big company which we have worked with was a big car manufacturer in Germany who has factories worldwide. And what we saw there specifically, of course, the first challenges to be met are actually not the technical issues. These are communication issues with the people, of course, because we need to bring everyone on one table. If we would like to bring all the information together from the different production facilities and even from the different company divisions, then we need to be able that everyone agrees on some common ground. Yeah, we need to have a big agreement between everyone, and this talking to the people and this cultural change and this understanding of the need that we need to bring all this information together. That is, of course, the time-consuming part. It's not a bad part either, because people have to think about what kind of information they can offer, and they need to think about how we can bring this information together and what data they really have. Yeah, so this is a very fruitful process, because everyone will understand their business from a new perspective and from a in a different way. Yeah, but actually this change in the organization, this cultural change to bring all the information together and make everyone recap on what information they truly have, this is the most time consuming and also the most difficult part, of course, to raise this understanding, yeah, and to raise this change culture.
Okay, great. Thanks. Okay, another question, right? So we are talking about this current COVID-19 situation and all that, right? So um, can you give us like an example, what how a company with industry 4.0 capabilities, or big data capabilities whatsoever, versus a companies without, right? So what would a company with these capabilities would see in terms of benefits versus a company without, right? And so how this will impact post COVID-19 as well.
Yeah, of course. I mean, like the first and obvious advantage would be that with the ability to automate certain processes, we can at least apply to the distancing rules very well, right? So we are really able to maintain our strict rules which we have right now, if we are able, let's say, to automate some quality control mechanisms, yeah, or to gather data from remote, so that people don't have to run run around there to bring information together and to capture information. This can be very, very beneficial if we can do this from remote. The overall work and business model, work from home and keep the production running from home. Yeah, if you have Industry 4.0 solutions in place, you only need, let's say, 10% of the people on site. Yeah, you have all this automation in place, and this actually enables you to be way more flexible, especially in this kind of situations which we have them right now. This would be a major improvement, I would say, and many companies would not lose so much revenue right now in this difficult situation if they had the capability already right now to yeah, use this Industry 4.0 technologies.
Okay, thank you. So we have a question here.
Yeah.
Okay, so first of all, she or he mentioned, thank you for your presentation. And she's curious, in companies with agility, right? Do you think big data integration helps?
Yeah, of course. I mean, first of all, big data and analytics is part of an agile company. Big data is especially used in companies where agility is in place. Agile means to adapt to new situations. Agile means to constantly look for improvement. Agile, to be agile is the opposite of stagnation. And this is especially what big data strives for. Big data strives for organizational change whenever and wherever it is needed. And any agile business model and any agile company strategy perfectly complies with the goal of big data. Because big data is really the goal for curiosity, to discover new things, to discover new correlations, and to discover new ways of doing things and new ways of understanding things. So I would say a big yes. Yeah, especially company with agility, with change management, and with the willingness to evolve, they can profit from big data analytics most. And all companies who are not agile right now, they should really start thinking about going from the static, let's say, project management model to some agile concept. Did I understand your concept of agility right, or did you mean some different agility aspect with your question? Okay, thanks.
Okay, so any other questions? Looks like we don't have any more questions. Any participants who would like to unmute yourself and ask any questions? Otherwise, we can end the session. No? Any question in the Facebook? No. Okay. So with that, I think we can end our session today. So once again, thank you, Dr. Hoffman, and to all participants for your participation. So we appreciate the time that you have allocated for being with us. Hopefully this talk has benefited all of you. For those who have missed, our first part until part 4, you can actually visit our YouTube page or Facebook page and watch all the videos over there, right? So this is a webinar series with 5 parts whereby we cover from the beginning of from the introduction of Industry 4.0 all the way to big data, right? So, okay, so ladies and gentlemen, this talk is brought to you by Steerix, MPCE, PN, and MGCC. So if you need any assistance, kindly email us at info@steerix.net. So till we meet again, please take care and stay safe.
Thank you. Goodbye.
Thank you.